Hello everyone. Today we'll be solving question 283, move zeros. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Okay, so in this question, what you have to do is, from seeing this example, we can see here that we are given a nums array and then we have to move all the zeros to the right side while maintaining the same orders 1 3 12, same 1 3 12. Okay, and for size 1 we have to return at this same way. Okay, so we have four approaches to discuss in this video. First, we'll discuss the brute force approach to solve this question. So the brute force approach says that what we can do is we can travel the array once. Then, if we encounter a zero, we start another traversal. Okay, and in this new traversal, we'll find the first non-zero and swap. Okay, and after swapping, we can break. So, let's say we encountered a zero over here. Okay, now what we can do is we can traverse the rest of the array. Okay, we traverse the rest of the array, and we find that the first non-zero element, okay, the first non-zero element is 1 over here. We have to swap it. Okay, we have to swap it, and then we'll proceed with the further iterations. Okay, so as you can see here, uh, we need a stable rearrangement of the elements. Okay, in this we need a stable rearrangement of the elements. All zeros at the end of array, the relative order remains same. We can see that the worst case will be that for each zero, okay, for the each zero we have to traverse the whole array again and again. Now we encountered a zero again, we have to traverse the whole right array. Again we have to traverse the whole right array. Then only and then it will be an O of n square approach. Okay, so you can see that's a very small input for an array, but if the input is large it will be very slow. Okay, so let's visualize this one. Okay, so as you can see, it's the same array as above one. Now the f and z means the first non-zero. Okay, so what you can do is I'm over here for while iterating. I'm over here. Okay, I encountered a zero. Okay, so I will traverse the rest of the right side of the array, and I'll pick the first non-zero, which is 1, first non-zero, which is 1, and I'll swap them. Okay, and we will have array like this. Then next time what we'll do is we'll will be over here. Okay, will be over here. Now we'll swap again. After traversing from here to here, we'll traverse this part. 0 will be rejected, this will be accepted, and we'll swap 0 with 3 and we'll reach this. Okay, again what we are going to do is we'll be iterating over this one. Okay, we'll be iterating over this one. Now will again traverse the array part here from this part to this part, the right side, and this is 0 is rejected, this 12 is accepted, and I'll swap them. Okay, so this is the brute force approach. Let's code this one and we'll see other approaches. Okay, so int n is equal to nums dot size. This is a utility. Now what we have to do is we have to iterate once. Okay, so for int I equals 0, I less than n, I plus plus, if nums of I equals 0. Okay, if nums of I equals 0, then what we have to do is we have to start another iteration. Okay, over the rest of the right side array. Okay, for int j equals I plus 1, j less than n, j plus plus, and here what we have to do is if nums of j is not equal to 0, then what we have to do is we have to swap nums of I and nums of j, and you should break, because after the first swap, we can just break through and we'll iterate on our outer loop. Okay, so we have to break over here, and then this should work. I'm missing something. Okay, I'm missing this case. Okay, so since we are trying to access something out of scope here, if we pushed an array of size 1 and the constraint are given from 1 to 10 to the power 4, so what you can do is we can create a special case for just one element, because in one element there will be no swapping required. So if n equals 1, return, and there's nothing after return because it's void function. Okay, so let's test this one, and our test case is accepted. Let's submit this. So yeah, it takes a bit of time complexity, because obviously it's O of n square. So we have seen this one method that will work. Okay, now what we have to do is we have to see other methods that can work. Okay, the next one is the extra array path that is simply not allowed in this question, but we'll still discuss this. So the question says, note that you must do this in place without making a copy of array. But I think we have to try once that we can do it without, we can do it if we can do it with. Okay, so this extra space approach is O of n. Okay, this is, we are trying to optimize our solution. Okay, so the same constraints given in the last part, what we can do is we can create a new temp array and then push all the non-zeros after iterating over this element. Okay, after iterating over all this, we can push, like say we reach 1, we'll push it, we'll reach 3, we'll push it, we'll reach 12, we'll push it, and after that we'll fill the remaining position with zeros. Okay, so step 1 will be creating temp, step 2 will be pushing all non-zeros, and step 3 will be filling the remaining. But this is against the question, because the question has a constraint of using space complexity as O of 1. Okay, so let's just code this one and then we'll move to the other methods. Okay, so in this one I have to create a new array. Okay, vector int, yeah. Okay, now what we have to do is we have to push non-zeros. So first iteration for int I equals 0, I less than n, I plus plus, if nums of I is not equal to 0, then only we are going to push, right? So temp dot push back nums of I. Okay, we'll push temp nums of I, and to fill the rest of the array, or to count how many number of zeros that we have, either we can iterate again, or what I'll like to do is for, okay, so while temp dot size. Okay, so the size of temp is less than nums dot size. Okay, so till the time, okay, you can see the size of nums is 5 and size of temp will be 3 till step 2. Okay, so 3 is less than 5, so 5 minus 3, so we need two zeros over here. Okay, so this will fulfill our condition, temp dot push back 0. Okay, we'll push back 0, and since that's a void function, we cannot return something. What we have to do is we have to assign all the values of temp to num. Okay, so this is our code. First we'll loop, second we'll push zeros, third we'll reassign the nums. Let's run this. We are unidentified temp. Okay, I named it ARR. Let's name it temp. Okay, So it's accepted. Let's submit this. And yeah, so obviously runtime improved because we have used often time complexity and offense space complexity. Okay. So this is another method, but it requires extra space, so it's invalid according to constraints. Now we have a to pass method. Okay, let's discuss this to pass method. So in this to pass method, what we have to do is we have to override values. Okay, so what we can do is uh, initialize a right pointer k equal to 0. Okay, so you can see k equal to 0. Okay, then traverse the array and copy each non-zero element to arr. Okay, so I traversed here. Okay, let's say k is equal to 0. I'm here. As I iterate, I reached a non-zero element. I'll rewrite it and I'll k plus plus. Okay, same way I reached here, my k was here. I'll just rewrite this one over here with 3. Same way I reached here, I'll rewrite this with 12. So after the whole traversal, my array should look like this. So 0 is replaced with 1 is replaced with 3, and 3 is replaced with 12. So all the non-zero elements are replaced in the starting. Okay, and after k, okay, fill the rest values with 0. So my k will be here. Okay, so from k to n, I'll fill the rest with 0. Okay, so let's try to code this one. Okay, so in this one, to do this, we have to first have a k. Okay, so int k, a right pointer, is equal to 0. Then we have to first in first iteration we have to put all non-zeros in the beginning. So for int I equals 0, I less than n, I plus plus, if nums of I is not equal to 0, if it's a non-negative or non-zero term, then we have to nums of k is equal to nums of 0, nums of I, sorry, nums of I, and then we have to increment k, right? So k plus plus. Okay, so by this from this for loop we'll be able to reach this one, post traversal one. Okay, now we have to fill the end part with 0. Okay, so now what we have to do is for int I equals k, I less than n, I plus plus, nums of I equals to 0. So I have to assign 0 to the rest of the array. Then we have to then we don't have to do anything, as we have changed directly in the original array. Okay, let's run this one and let's submit this. So this way we have solved this question using two pass approach. Okay, so the first pass will be for collecting all the non-negative in the starting, and the second pass will be to assign zeros at the end of part. Okay, so the first part is to build this, second part is to build this, the final answer. Okay, so this is a two pass override approach. Now if your challenge is to not to override, okay, we can't override it, we have to use swap mechanism. In that case, what you can do is you can use this one pass approach. Okay, so the one pass swap is uh, this another solution to this question. Okay, so in this case what we have to do is we have to initialize a store variable. Okay, and we'll traverse the array, right? If a non-zero is encounter, we'll swap with nums of store, and then we'll just increment the store to store plus plus. Okay, so let's visualize this one, how it's going to work. Okay, I've built a visualization for you. So first we'll assign initialize the store variable as step 1. Yes, initialized it. Next what we have to do is Once we are here, now what we have to do is we have to iterate over the array. Okay, so first I is equal to 0, we have 0 over here, so there will be no change, right? There will be no change. Next iteration, there's I equal to 1 will be here. Okay, I equal to 1 will be here. So since it's a non-zero, we have to swap them. Okay, we have to swap them with each other. So finally we'll be have something like this. Will be we'll have swapped this 1 and 0 with each other. Okay, next iteration, what we have to do is we will go I plus plus, and then we encountered another 0, so we are not going to do anything. Next iteration we encountered 3. Okay, next iteration we encountered 3. What we're going to do is we are going to swap it with store, and then uh, we are we'll go store plus plus. Okay, store plus plus, the store will be here. So in this iteration you can see store will be here. And for next I, when I will reach here, store is here. We see store with 0 and I with 12. We are going to swap them. Okay, so this is, so after these 5 iterations, we have a final answer with us. Okay, so let's see how you can code this one. So you can use any name for store. I can also use k, or maybe for better verbal, use store. Okay, store equal to 0. So in one pass we are going to do this for I equals 0, I less than n, I plus plus. Okay, if nums of I is not equal to 0, if we encountered a non-negative, then a non-zero, then what we are going to do is we are going to swap store nums of store and nums of I, and then we are going to do store plus plus. Okay, these were the, this you can see this how simple this one is, right? So we literally have to just initialize the store, and there's one for loop. If nums is not equal to 0, then we have to swap and we'll store plus plus, else it will be fine. Okay, let's run this, and it's all. Let's submit this. So yeah, we have done this question too with all the 4 approaches that we could have used. There could be more approaches to this question, but these were like the one of the best ones to solve this. Okay, so thank you for watching, and I'll see you in the next one.